Okay, so the next example I want to do for you here is kind of a real-world example that will show you how you could measure distances. It says that we want to know the distance to a ship at sea, and we can do that by solving a triangle that we know and one that we don't using these angles. So if these angles are congruent, then if we know this triangle, we will know about this triangle. So I am given that TRS and TRL are right angles, and I am told that angle RTS and angle RTL are congruent, and I want to show that RS is congruent to RL, because I could find RL because I could go measure it, or I could ask somebody. That's like a known distance, and then the distance RS, the distance to this boat, will be the same. Okay, and this is something that this Greek philosopher they're talking about actually did. Okay, so I need to prove these triangles congruent, and the way that it works is this. First of all, I was given angle TRS and angle TRL are right angles. So that was given. I don't think, you know what? I think I'm going to have to do a flow proof because I'm not going to have room to make a table. So that was given. And also I was given RTS congruent to RTL. And that was given. Okay, now I know that TRS, angle TRS, is congruent to angle TRL. And this is because I proved for you in kind of a quick way that all right angles are congruent to each other. So all right angles congruent. That's my symbol for angles. Congruent. Okay? All right angles are congruent because they all have the same measurement, aka 90 degrees. Okay? There, I just proved it for you again in a really short, quick way. So I know these two angles are congruent, and I know these two angles are congruent. Finally, TR is congruent to RT by the reflexive property, or you could say it's a shared side in these two triangles. Here's my two triangles, lovely triangles. Not really. Maybe I could do better. I don't know. Let's see, can I do better than that? I don't know. I feel like I have to try. So here, whoops. I know you're thinking that's not better, but it will be. There you go. There's one triangle. And oh, I thought I could flip it, but I guess you can't, so I won't. Okay, and there's the other triangle. Okay, so I'm saying these two triangles are congruent. This side is shared by both. Now, I showed two angles are congruent. So this is reflexive, by the way. So I showed two angles are congruent. This pair of angles and the right angles. And I showed this side is the same for both. So by angle, angle, side, we have triangle TRS congruent to triangle TRL. And since the triangles are congruent, their individual pieces are congruent. So that means that RS, segment RS, is congruent to segment RL, and that is by corresponding parts of congruent triangles are congruent. CPCTC. Okay? So what did I do again? I was given two angles. I found a shared side. I proved the triangles were the same using angle, angle, side. And if the triangles are the same, each of their parts are the same. Okay? Let's do one more. BA congruent to DA, so right there. CA congruent to AE. I want to prove that angle C is congruent to angle E. Well, first of all, I know in addition to this, and I'm not going to restate it this time just to save time, we already know these things are given to us. So the next step is, I know EAD, angle EAD, is congruent to angle CAB. And how do I know that? Well, because these are vertical angles. So I guess I'm doing a two-column proof this time. Vertical angles. So I know two sides and the angle between them. So by side angle side, I have triangle CAB congruent to triangle EAD. Okay? So the triangles are congruent. That means the C and the E are congruent. By corresponding parts of congruent triangles are congruent. Okay, so there's another proof for you. Hopefully you enjoyed it. I really actually kind of like proofs. They're kind of neat, whether it's a paragraph proof where I was typing things out, or a flow proof, or even a two-column proof. So hopefully you found this as cool as I did.